Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we uncover how NASA's James Telescope spotted a distant supernova, allowing scientists to look back to the universe's earliest era and witness one of its first cosmic explosions. That fleeting signal carried clues from a time when the universe itself was just beginning to take shape. An international team of astronomers have detected a supernova that exploded when the universe was only about 730 million years old, placing it deep in the era of ionization, according to phys.org. It also provided the most distant direct evidence yet of a stellar explosion from the early cosmos. This was the period when the first stars and galaxies were forming and transforming the newborn universe. The event was associated with a bright burst of gamma ray labeled GRB 250314A. Webb's sensitive infrared observations helped in detecting and distinguishing the fading light of the explosion from its faint host galaxy. The supernova was initially flagged in March 2025 by a gamma ray burst detected by the space-based Variable Objects Monitor. Gamma ray bursts are explained as intense flashes of high-energy radiation, often linked to catastrophic events such as the collapse of massive stars. Follow-up observations with the European Southern Observatory's Very Large Telescope in Chile confirmed the extreme distance implied by the signal. Details of the discovery are described in a study recently published in the journal Astronomy and Astrophysics. Roughly 110 days after the initial burst, James Telescope captured near-infrared images using its NIRCam instrument, thus enabling scientists to isolate the light from the supernova itself and study its properties despite the enormous cosmic distance. This supernova is not just the most distant ever directly observed, but also closely resembles certain similar explosions seen in the nearby universe, such as the well-studied GRB-associated supernova, SN 1998BW. Analysis indicates that the massive star which exploded in the early universe had spectral and brightness characteristics comparable to those of long-duration gamma-ray burst-associated supernovae seen much closer to Earth today. The findings challenge the assumptions that the early stars, formed under environments with extremely low metallicity conditions, would behave very differently from their modern counterparts. The research team, according to phys.org, plans to secure a second epoch of James Telescope observations in the next 1 to 2 years. By that time, the light of the supernova is expected to have faded significantly, thus allowing the team of astronomers to completely characterize the properties of the faint host galaxy, thus confirming the contribution of the supernova. Thanks for tuning in to this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.